A force is a push or pull resulting from an object's interaction with another object.
A common misconception about force is that it is required to keep an object in motion. That is not actually the case. The force is just required to start the motion initially.
When working with forces, you have to keep in mind Newton's 3 laws. First law.
An object in motion or at rest will stay in motion or at rest unless opposed by an outside force. Here on Earth, this cannot easily be observed because of the force of friction between an object and the ground. So, let's go to space. Here we are in space where there's no gravity. That object will stay in motion until another force opposes its motion. Now let's go back to Earth. A common misconception is that an object in motion will naturally come to rest. However, that is not the case. That is due to the force of friction between the object and the ground on Earth. That makes sense, right?
Second law.
Newton's second law says that mass m times acceleration a is equal to the force F. Acceleration and force are vectors that go in the same direction. You need to know this equation to master forces.
Third law. Newton's third law states that for every action, there is an equal and opposite reaction.
Ah! That hurt! I wonder why.
Wow, Andreas, that is actually a perfect example of Newton's third law. You see, when you go to punch the wall, the action force that your hand exerts on the wall is exerted equally back from the wall onto your hand, the reaction force.
A force body diagram is a way to show all the forces on any given object. These can be very helpful when solving equations dealing with forces.
Here we have the most basic free body diagram. This free body diagram can represent any object on Earth because of the gravitational pull downwards. This is represented by this arrow and is also mass times the acceleration due to gravity. However, we are not falling down through the Earth. This is because there is a force pushing upwards back on us. This is represented by this arrow and is called normal force.
Let's further investigate this free body diagram. As we know, the sum of all forces equals the mass times acceleration. Alex's mass is 25 kilograms, and he's not accelerating in either direction, so his acceleration is 0 meters per second squared. Therefore, the net force acting on him is 0 newtons. But how can that be possible?
The only way for this to be possible is if the forces are equal and opposite. So in this situation, we can solve for mg, because we know the mass, 25 kilograms, and gravity, the acceleration due to gravity, is always negative 9.8 meters per second. So if you multiply them together, you get negative 245 newtons. So we know that the equation Fn plus mg equals 0 newtons. We plug that in. Fn plus negative 245 newtons is equal to 0 newtons. So it's simple to solve for. All you have to do is add 245 newtons to the other side. That way we know normal force is equal to 245 newtons. There are other forces than Fn and mg. One example is tension force, a force between a rope and an object. Another is applied force, the push or pull on an object. Another is the force of static friction, which is friction between two objects when there is no motion involved. And then force of kinetic friction, which is friction when there is motion involved.
This is a free body diagram of the forces on Alex. Like before, he has an mg and an Fn. But this time, he's accelerating that way because I pushed him.
Look, the mouse found its way back to Earth and is now hanging from a wire. Let's do a free body diagram. Here is a free body diagram for the mouse. As we know, it is hanging from a wire. Therefore, there is a tension force and is not accelerating. So, the mg must be equal to the tension force.
Remember the book? Let's do a free body diagram for it. Here's the free body diagram for the textbook. Notice there is an mg and an Fn, and they are equal because the book is not accelerating up or down either direction. However, it is accelerating to the left. This is represented by the applied force when we go to actually push the book. Now, because it is on the ground, there is a force of kinetic friction. However, notice it is smaller than the force applied. This is because it is accelerating to the left. Here's the free body diagram after the book has been pushed. Notice it is the exact same except there is no longer an applied force. This is because nobody is pushing the book anymore. There is no force being applied to it. It is currently moving to the left, however, it is slowing down due to the force of kinetic friction. The problem we have here is a boy pushes a box of a mass of 25 kilograms, and it moves at an acceleration of 5 meters per second squared. With what force does the boy push the box? So we know from Newton's second law that we have the equation sum of all forces equals mass times acceleration. And we know from the problem that the mass is equal to 25 kilograms, and the acceleration is equal to 5 meters per second squared. So that means that we can just plug in the mass and the acceleration, and we can get the sum of all forces is equal to 25 kilograms times 5 meters per second squared. And it's just some easy math. The sum of all forces is equal to 125 newtons. In this problem, we have a box with a mass of 50 kilograms is being lifted with an acceleration of 2 meters per second squared. What force is required to lift the box? So to start off, we've created a free body diagram with the tension force being greater than the mg because the box is accelerating upwards. And thanks to Newton's second law, we know that the sum of all forces is equal to mass times acceleration. The mass being 50 kilograms and the acceleration being 2 meters per second squared. So we plug that into the equation and we get the sum of all forces equals 100 newtons. Now what exactly does the sum of all forces mean? Well, that means when you add up all the forces. And in this situation we have two forces, tension force and mg. So if we add them together, they have to equal 100 newtons. We can solve for mg, however, and we can plug in the mass of 50 kilograms, and the acceleration due to gravity is always negative 9.8 meters per second squared on Earth. So when we multiply those two together, we get tension force plus negative 490 newtons equals 100 newtons. All we have to do is add 490 newtons to the other side and solve for the tension force. The tension force is equal to 590 newtons.
May the forces be with you.